Hi everyone, so this is a continuation video on solving scalar nonlinear equation, but today we're going to show how to solve this nonlinear equation using Newton-Raphson method. So let's just recall the other iterative methods such as bisection method. So there are actually three methods: bisection, secant, and Newton-Raphson. So bisection method, what it does here, let's say I have this equation here. Okay, so for fx equals to 0, okay, so I have three roots here, 1, 2, 3. Now bisection method need use intermediate value theorem, it's called the bracket approach, to find or locate the root in this interval. So depends where your interval is. If let's say your interval is here, so it will use a bracketing approach where it will evaluate the function and determine if the root is here or not. So let's say with the bracket you find this value and then you keep going until you find here, and then you keep going until you find here the root. Okay, and similarly if you choose the interval from here to here, so it will check using the intermediate value theorem. If the root here, it will continue the process and find if the root here, it will continue the process until it finds the root. So it can be this way, it can be this way, or it can be alternate bracketing. Okay, so it's a bit slow, I would say, unless you find exactly, you know, where the roots are and use the correct interval. Okay, so this is bisection. Now, secant method. Secant method, what it does, let's say I have the same graph. Okay, so now let's say I want to find the root here. So secant method, what it does here, it will use a tangent line. Okay, use a tangent line for the given interval. Let's say my x of 1 and x of 0. So these are the two intervals it uses, and actually the other way around, let me erase it, is 0 and 1. Always write the smaller interval first. Okay, now with these two intervals, it will use a secant formula. Secant formula to alternately find the root. So you start with here, and then it will cut through again, start from here, cut through again, until the line touches the root at fx equals to 0. So this is a secant approach. Okay, so it has two initial value and it uses equation of a tangent, pretty much modified equation of a tangent to find the root. Now today what we're going to look at is another iterative method using Newton-Raphson. This is very famous method, very powerful as well. Okay, so Newton-Raphson method uses the slope of a tangent. Okay, so if you remember the slope of a tangent, so for example, okay, let's look at equation here, and I have, let's say, something like this. Okay, now this is the root. This is my root at fx equals to 0. So what it does, it has, sorry, my line is not straight, so it uses tangent line, which is the derivative x, whatever the starting point is. If this is my x at k minus 1. Okay, so this is the idea of the Newton-Raphson method. Now, if you recall, the tangent line, or the slope is given as f of x k minus 1 over x at k minus 1 minus x at k. Okay, so what we want to find is, we want to rearrange. So this is m here is my f prime x k minus 1 equals to, so normally what you say is, you say y2 minus y1 over x2 minus x1. That's the lame formula for that. So we rearrange the equation. So for example, this is my root that I want to find. So multiply, bring it to the other side. So I have k f prime at x k minus 1 equals to f of x k minus 1. Okay, so what I do here now, xk minus 1 minus xk equals to f of xk minus 1. We divide with the derivative of f prime xk minus 1. Okay, so therefore, what is my x of this one? This minus with that. So we can say that the root, to find the root, I need xk minus 1 minus f of xk minus 1 over f prime xk minus 1. Okay, so this is the famous Newton-Raphson formula. Okay, this is the Newton-Raphson formula. Okay, let's look at one example. I hope one quick example will be, so let's say find the root. Find the root of x plus ln x equals to 0. So we need a starting value. It will be given. If it's not given, we have to look at the graph and find any initial. So we want to iterate. Okay, so iterate. Let's say a few iterations. We want to do that using Newton-Raphson method. Okay, so the idea is pretty simple. The first step is to, so we need one initial. So we need to use one initial. So this is my x0. And then the second step will be, we need to find the derivative. F prime xk minus 1, another way my x are 0, and f of xk minus 1, the derivative and the function. And then we use the Newton-Raphson formula. To find xk. Okay, these are the 3 steps you need to work it on. Okay, so I'll just show you a simple example for this one. So this is the function fx equals to x plus ln x. So the derivative of this, f prime x, will be 1 plus 1 over x. Okay, in this case it's pretty easy. Now my x0 is 1, so f of 1 will be 1 plus ln 1 Okay, and we know that ln 1 is 0, so this will be 1. And then for this one, f prime 1 will be 1 plus 1 over 1, which is 2. Okay, so how do you find the first iteration? My first iteration will be x1, so for k equals to 1, x0 minus f of x 0 over f prime x 0. Okay, we know that our x0 is 1, so we have 1 minus, now this equation, 1 over 2. Okay, so we have 0.5000. Okay, now you continue the process to find k equals to 2. So for k equals to 2, now to find k2 will be x2 equals to x1 minus f of x1 divided by, oops, let me just undo quickly. Okay, so okay, so we have f of x1 over f prime of x1. Okay, so you need to find f of x1, which is this one, 0.5. So f of 0.5, which is 0.5 plus ln 0.5. This is a function that we are looking at. Okay, so by pressing the calculator, I think there's a negative 0.1931, and the other one is f prime 0.5, which is 1 plus 1 over 0.5. So 1 plus 1 over x, which is 0, x is 0.5, 3.0000. Okay, so by obtaining these two answers, we can substitute to find x2, which is x1 0.5 plus f of x1 negative 0.1931 over 3. And by putting into your calculator, you will obtain 0.5643. Okay, so you can continue the process. So like I said, you continue the process when you obtain f of x to the k. Okay, f of x to the k equals to 0, or f of x to the k, the magnitude of this less than epsilon. Epsilon is a very small number, and normally the question will give you what's the epsilon. Okay, for example, epsilon can be 0.005. Okay, so the function. So this, don't look at the derivative, look at the function here. So whatever k value, if it's less than 0.005, you stop the iteration, and your root will be whatever your value of x at that moment. Okay, so this is Newton method here. So you have learned 3 iterative methods such as Bisection, Secant, and Newton method. So in terms of convergence, so Newton method converge faster than Bisection and Secant because Newton method has a quadratic convergence. Okay, Secant method, the convergence is approximately 1.6, superlinear. Okay, in Bisection method, it has a linear convergence. Okay, obviously Newton-Raphson method converge faster due to the quadratic convergence. Okay, so that's all for today. So see you in the next class. Thank you.